Hi. So, as you heard, I'm Aaron. I am the lead maintainer for Clang, and I just want to kind of give a whirlwind tour of, where are we at, what have we been doing in Clang, and kind of where are we going with it, and how do people think it's going for us? And mostly focusing on us as a C and C++ compiler for this. So, starting off, we should figure out, what have we been doing for Clang 17, Clang 18, Clang 19, kind of what's happened recently. And one of the things we've done is we've been focusing on C++2C and C2Y. These are the next iterations of the C++ standards and the C standards. We started working on these in Clang 17, and we've been expecting to see C++2C in 2026, and we're expecting to see C2Y sometime this decade. Both committees have kind of a different approach to how they do their standardization, but we have started working on both of these standards since Clang 17. So far, neither one of the standards has added anything that is like transformative and a major implementation burden for us to deal with. Mostly it's been small features and bug fixes and that sort of thing. But we do expect there to be some large-scale things coming down the pipeline in the future as the standards committees continue to work on their features. So what have we been doing for C++2C? In Clang 17, we added the ability to have user-generated static assert messages. These are static assert, instead of taking a string literal, can now have a constexpr string, basically, so you can call functions and have a more robust generated message for things. We also worked on constexpr cast from void, which allows constant expressions to smuggle data through void pointers. Clang 18, we added unevaluated strings, which is really mostly just a language cleanup thing that says that strings that are compile time strings have a particular encoding to them, but it's not necessarily related to the runtime encoding. More interestingly, we worked on placeholder variables with no name. These are especially useful for things like structured bindings, where you have one field that you want the name of and the third field you want the name of, but you don't care about the second field. So instead of having to invent a name for that thing, you can use the underscore, and that just tells the compiler, like, there is an identifier here, you should never actually name it, you're not going to be using this variable. In Clang 19, speaking of structured attributes, structured bindings, we added the ability to add attributes onto the structured bindings individually. And another one that we worked on in Clang 19 was equals delete should have a reason, which when you have a deleted method that's selected, you now can actually have extra diagnostic information for it that's user generated. But that's not all. We've been really working on 2C. Other things that we've been doing is trivial infinite loops are not undefined behavior. You might have seen this one going around on social media quite a bit, where you had a main function that had a trivial infinite loop, and then you had a completely unrelated function that's not being called anywhere, and you would run it in an optimized build, and it would call that function. That no longer happens. We've closed that little loophole, and yeah. So another one that we worked on in 19 was pack indexing. So when you have a parameter pack or something along those lines, you no longer need to iterate over the pack to get to the nth element. You can just ask the compiler, please give me the nth element out of this pack. So that helps with compile times and that sort of thing. Another 19 one we did was disallowing binding a return to GL value to a temporary. Basically, that was a case where we would get dangling references quite easily, and we realized we don't need to do that. We can catch that statically at compile time and just make it an error, so it's basically closing a foot gun for people. And then Clang 18, going back a step, the C++ committee removed conversions from arithmetic types to enumerations and vice versa, and this actually turned out to be really disruptive to our users. So we implemented it in Clang 18 as an error, and then we very quickly realized that it needed to be a warning that defaults to an error so that users could have a transition period to it and be able to downgrade that into a warning. But in Clang 20, that is now back to being a hard error. At least that's the hope. We'll see how users react to it and whether we've had enough time for the users to transition. So we've also been working on C2Y. This one is interesting in that the C committee oftentimes just they standardize existing extensions from a lot of different implementations. And so a lot of the work we've been doing on C2Y is mostly just testing that the things that have been standardized are things that we're actually conforming to. So for example, complex literals, we have the I suffix and the J suffix, and this is something we've supported forever. And that was just standardized for you to be able to specify a complex literal. Another one that was really weird is you couldn't increment or decrement on a complex value, which was kind of nuts because everybody was allowed to, like every implementation of complex had support for this sort of thing. So we just standardized it and said, okay, this is blessed. One of the more fun ones for C2Y was type of and type of unqual. These features are kind of like decal type in C++, where you're able to get the type of an expression, and the type comes with the qualifiers attached to it. So that's why there's a type of unqual, is to get the type with the qualifiers stripped. But this actually works nicely with another feature that was added to generic selection expressions in Clang 17, where the way those things work, for those who aren't familiar with the weird things that C does, this basically allows you to say, given an expression, I want to match whatever the type of the expression is so I can delegate to something. So for example, you can have a macro named sign, and it can delegate. If it gets a float, it delegates to sign F, and if it gets a double, it goes to the regular sign, and if it gets a long double, it goes to sign L. The problem with that was the fact that generic selection expressions worked after all the qualifiers were stripped off of the type. And so you couldn't actually match on every type in the type system, and that's kind of a problem in certain circumstances. So it now is allowed to take a type operand directly, which works really nicely with the type of operator, because you can say, given this expression, get me the type of this thing with all the qualifiers still attached to it, and now I'm going to match on the fact that it has qualifiers. So we've also been working on C++23 and C23. These were both ratified by both standards committees in 2023. They're final, but ISO being ISO, they just published the C++23 standard like this week, end of last week. So it's, it is now finally published. And C23, we don't know when ISO is gonna get it published. But the thing is these are final. The standards committees consider them to be final. They are called C++23, they are called C23. If you see Wikipedia articles calling it C++24, they are wrong. Clang 19 has been, we've been working on these for quite a while, and Clang 19 is almost C++23 feature complete. One of the big things we know we're lacking support for currently is context for math. We're hoping that we're going to be able to share a bunch of code with LLVM libc for doing a lot of that implementation work, if possible. So that way we don't have to duplicate effort across the projects. But that's a significant undertaking because there are a lot of math functions that are now constexpr. We also lack support for unknown pointers in constexpr and explicit lifetime management. The last one would be start lifetime as, a library function that needs compiler support. And Clang 19 also has a lot of support for C23. One of the big ones we're missing is decimal floating point support. But we also are missing some of the smaller features like adding storage class specifiers on compound literals and that sort of thing. So what we've already done for C++23 is we've done deducing this. That works kind of like Python's self object in that you can deduce the CV qualifiers off of that object. We also relaxed some constexpr restrictions, which allows constexpr functions to do more things, which is great. One other one we did was portable assumptions. This was a rather contentious topic in the standards committee in that most of the implementers said this is not going to do what the users expect. We should probably not do this, but the committee felt otherwise. And so we have this attribute called assume, which allows you to tell the optimizer more information that it can assume. And as Nikita mentioned yesterday, LLVM doesn't forget that very readily. And so you actually end up pessimizing your performance more often than not. And because it's an optimizer thing, as soon as you mutate the code or you go to another compiler or you upgrade your compiler version, all those assumptions are no longer necessarily valid. So you have to constantly retest and retest and retest if you're using this. But it is something that we implemented in Clang 19 and we do have full support for. Also working on C23 features. So Clang 18, we removed trigraph support. How many people remember that was a thing? So that's for parity with C++ 17. One of the other ones in Clang 18 that was really interesting, though, is we added auto, that just came from C++ as well, to be able to deduce the type of a variable. This only works with object definitions, though. It doesn't work for things like function return types or function variables. We don't yet have template-y type things in C. So this is just for the object declarations. Another one in Clang 18 that was actually a really annoying thing for a lot of people is free positioning of labels. So you write a label, and if you could only put a statement after that, you couldn't have a declaration, you couldn't have a closed curly brace. You had to put a semicolon in there in order to make that sort of thing work. And so with C23, we just decided from a language perspective, we'll pretend there was already a semicolon there and move on, and now you get your declarations and your closing curly braces, and it all works fine. Clang 19, we added constexpr for object definitions, and this is, again, another feature that came over from C++. You'll see this as a theme from the C23 time to release. But this is only for object definitions, so we don't have constexpr functions yet in C, but you can at least finally have a real, true, honest-to-goodness const object in C, which is great because a lot of people forget that if you have like const int I and then constant I equals 12 and then you use that in an array declaration, you just made a variable length array. Surprise. So now you can use constexpr and it's actually a const, and it will give you a statically sized array. And another big one from Clang 19 was embed. This is actually a really popular feature with users, and the basic idea behind it is kind of similar to include. With include, you take another file, you grab all of its tokens, and you slam them into the including file. With embed, you take a binary file, and you grab all of the binary bytes out of it, and you slam it into the embedding file as a comma-delimited list of integer values. And this is helpful for array initialization, where you've got like a 2 gigabyte object that you want to stick inside of an array. You're not going to type out all of those numbers by hand. Now you can just embed it, and you don't have to use linker scripts or funny tricks like that. We revised the spelling of keywords in Clang 17, so you no longer have to use _B bool or include a header file in order to use it. We've had a long enough transition period for users to get used to the prettier names, and so all of the keywords from C99 have now got pretty names. We also added nullputter and nullputterT, again from C++, which is a really helpful way to have a typed null pointer. Unreachable flow control. In C++, that's stud unreachable as a library function. In C, it's a macro named unreachable. There are reasons for this divergence. I'm not particularly pleased with it, but it is what it is. And then we have consistent initialization with open curly brace, closed curly brace, where it will now finally guarantee that it's going to zero initialize the entire object that you are trying to get initialized. So for C++ 20 and C++ 17, C++ 20 was a major evolutionary change in C++. It introduced some fantastically huge features like modules and concepts and the spaceship operator. And Clang 19 is almost entirely C++ 20 complete. The only thing we're missing is full support for modules, and I will get onto that one in a moment. But C++ 17 is actually interesting in that we finally are now C++ 17 feature complete as of Clang 19. That was thanks to some significant efforts from people on doing template resugaring and template argument matching. So that means that Clang 19 is now finally finished with C++ 17 features. So in terms of the stuff we've done on C++ 20, in Clang 17, we added support for const eval so that you can have real constant evaluation instead of it deferring sometimes to runtime if it has to. We also added support for operator spaceship. And Clang 18, we also have lambdas in unevaluated contexts in Clang 17. This allows you to put a lambda inside of a decal type. And then now you get the type of that lambda, so you could actually use it over and over again. So you could do, for example, recursive lambda function calls this way. And in Clang 18, we added generalized non-type template parameters of scalar types. You can use float as a non-type template parameter, for example. But the real big one is concepts. In Clang 19, we finally were able to define the feature test macro for it. And so you no longer have to use std enable if. to try and constrain template types. You could use concepts for it, and it is a much more natural, easy to use syntax. So what's going on with modules? So they were added to C++20, but we started working on modules in Clang 11. So it's been about 5 years worth of work that we've put into doing C++ modules, and it's still not complete. We don't define the feature test macro for it. But it's worth noting that despite us saying that it's incomplete, modules are actually really well supported in Clang. And so they should work for most everybody's usage patterns for things. The stuff that's still to be done, we're tracking in issue 112295. And the only two things that are really in there are diagnostics for TU local entities and module level lookup. So those sort of things won't work as the way that they should, but we're still working on them. The community is still actively working on this functionality, and we hope to get it completed in the future. So changing gears, I like data and I like graphs. Sorry, you're all subjected to this. But this is about how we're doing in terms of conformance. So on the C side of things, we're fully conformant to C90, and we have been for a long time. And we're almost fully conformant with C99. We're 93% of the way there, with only 7% that's just partially supported. And there are no C99 features that are mandatory that we simply don't have any support for. Our C11 story is pretty good too. We're 85% of the way there, but we have 10% that we're just not certain whether we're conforming or not. Because the C Standards Committee adopts a lot of extensions and that sort of thing, we just need to make sure that we have the test coverage that we actually are implementing what the standard says. And that's why there's so much in the way of unknown. So there's between 85 and 95% of C11 is done. C23, a little bit worse, 81%, but we're still doing pretty good. There's again about 10% that we're not certain on, but there's about 6% that we know we definitely still have to work on it. And then C2Y, 56% of the way done with those features, at least currently. And again, 24% that we still have to write the tests for. On the C++ side of things, we're fully conforming to 98, 11, 14, and 17 now, which is fantastic. And our C++20 support is 91% of the way there, with 9% partial, and that 9% is all in modules. So that's the only real thing that's left there. Our C++23 support is also doing pretty good. It's 89% of the way done, with 11% of things that we just haven't gotten around to finishing yet. And even though it's brand spanking new, the 2C support, we're 83% of the way done on all of those features as well. So switching gears a little bit and talking about defect reports. This is actually kind of a really interesting topic. So in C, since C90, there have been 427 total defect reports across the language and the library side of things, and we implement 47% of the ones that matter to the compiler. 35% of them, 36%, somewhere in there, just don't apply to the compiler. They're things that are not a defect. They're things that apply to the library. They're editorial changes we don't have to do anything about. And then we've only got about 2% of CDRs that we know we don't currently implement. And there's about another 9% that we're not certain on. By contrast, on C++, the language alone has just shy of 2,900 defect reports since C++ 98. And we have 54% that we just don't know whether we implement or don't implement. We just know that we have 21% that are done and 2% that are definitely not done. But there's a massive amount of unknowns there. And we have folks who are actively working on writing conformance tests for this. But the reason it's so important is that the C++ Standards Committee assumes that every implementation implements every single defect report that they have ever put out. And they base new features on the fact that you have implemented these. So because we have quite a few unknowns in this case, we're not certain where we're at in terms of being able to work on new features, because we'll frequently run into a problem where a new feature requires work from a defect report that we haven't implemented. And so this slows down our velocity on implementing new features, and is why getting a better handle on what we're doing for defect reports is so interesting to us. And so we have been fixing defect reports, but you notice on the graph, we were doing really good in early versions of Clang, getting a whole lot of them done, and then we kind of fell off. And it would just be very sporadic as to when we would get around to looking at them. But starting about in Clang 17 or so, that's when we started making concerted efforts to do more testing to complete our DR conformance tests. And so they're claimed as fixes per release, but in some cases it's already been working and we just have the tests that verify that it's actually working, so we can now mark it off as yes. The hope is that this graph continues to go up and up. So that was how we've been doing. Now, what kind of things are we working on? For C++ 2C, we already have variadic friends and context replacement new in Clang 20. There are folks who are working on reflection and contracts, even though these are not yet officially adopted by the C++ committee. And that work is happening in forks off the end of Clang as opposed to happening on mainline Clang. But we do know that folks are working on them because there are folks in the Clang community who are paying attention to the work that's happening there, or it's folks from our community who are doing that work in forks. For C++ 23, we've implemented lifetime extension for range-based for loops. That's a Clang 20 feature. But we still have to work on things like const per math and unknown pointers and references and constant expressions and that sort of thing. For C++ 20, obviously, we're continuing to work on modules. That's really the primary focus for that one. And then we still do a lot of extension work. So extensions like SYCL, extensions like OpenACC. And there's one that's kind of a stealth extension, I think, in that we've got folks who've been working on support for real-time analysis for real-time code. So there's a real-time sanitizer now that people have been working on, and there are attributes to be able to say this function should not be blocking. This function should never be called by something that's blocking, and that sort of thing. On the C side of things, we're still testing for a lot of our extensions for C2Y. That's just most of the effort there, but there are some new features. So for example, C2Y has if declarations that are similar to what is in C++, where you can have if and then you declare something in a semicolon and then a condition that's using it. For C23, some of the things that we've been working on recently for Clang 20 is enumerations with a fixed underlying type and improved normal enumerations, which is basically the fixed underlying type one is you can specify the underlying type of the enumeration as long or short or whatever you'd like it to be. But the improvements to normal enumerations are you can now have enumerators that are no longer just sized int. So you can have ones that are size long or long, and if you end up overflowing into the different types, it will just naturally figure out what is the correct type for the enumeration. We are also working on a lot of extensions in C. And one of the really popular ones is bound safety checking. There's been talks on it this week, but this is actually a very, very popular feature amongst users. They're really excited about this, and it is something that we are continuing to work on. And we've also been working on things like connecting flexible array members with the count so that we can have better diagnostics. And so both of these are really moving the needle on safety and security in C, which is great. Speaking of moving the needle on safety and security, we are continuing to harden diagnostics where we are turning things from warnings into warnings that default as errors because we want to help our users be successful, and it's really easy to ignore warnings. It's a little bit harder to ignore these warnings which default to errors. And of course, we're still working on conformance testing stuff. So what are people saying about Clang out in the wild? The first thing I need to do is give a caveat here. This is not scientific. This is some guy on the internet said. So take everything here with a grain of salt. So one of the first things people are talking about is performance. Obviously, that is the reason why people use C and C++ so much. And so performance really matters to our users. And it's nice to see that our users are finding Clang and GCC to be competitive at runtime performance, as well as Clang and MSVC. Sometimes Clang is better, sometimes MSVC is better, sometimes GCC is better, but we're all in kind of the same realm. And so it's really nice not to see like we're falling behind or lagging behind any of our competitors. But it was interesting to note that vector math apparently works really well in debug mode. It's actually more optimized than anyone else's vector math, which it's not what you would expect out of debug mode, and I don't think it's because we're doing any actual optimizations on it. It's just the base implementation of it is that good. On the flip side, though, we have compile time performance, and that is something that is very important to users as well. And they are noticing our compile times are getting noticeably slower, and sometimes that ends up being better runtime performance, which is fine, and sometimes it doesn't end up giving any better runtime performance, which is kind of unfortunate. But this does mean that our users are starting to use ftime trace a lot more, and they're not successful with it because we haven't really done enough with it to help them be successful. So this is an area we should work on to help users figure out what is slowing their compile times down. But it's worth noting that this is not just a Clang problem. C++ features are just adding a significant amount of overhead inside of STL templates and headers and that sort of stuff. And so this is impacting all vendors. You switch from C++ 14 to C++ 20 without changing your code, your compile times are definitely getting slower. That's just the nature of the language. Tooling. Tooling definitely matters to our users quite a bit. Clang Tidy and Clang Format are seeing a lot of adoption and a lot of love from people. They're getting increased usage inside of pre-commit CI pipelines an awful lot. But it's also been nice seeing people are integrating Clang Tidy into their build scripts. And so it's becoming part of the build process, which is really nice because you can write plugins for Clang Tidy, so you can have custom checks for your project that come in as part of your build process, which is nice. Clang Format being integrated into basically every tool under the sun, which is wonderful. And users are finding that the number of options are sometimes a bit overwhelming, but because formatting is such a personal choice, it's such a stylistic choice, they also really appreciate the number of options we have and that they can really tune it to exactly what they want, which tells me that we're making a really good mixture. We're setting a good, we're getting to actually a really good point where it's not too overwhelming, but we still have enough that people are able to be successful in formatting whatever they want with it. And then Clang D is becoming very, very popular. I was seeing a lot of VS Code users who are really happy with it, but it's flexible enough to be used as a language server with basically any kind of tool you want for doing things like jump to this definition or which include files do I need to have, those sort of features. So another constituency I was looking at was standards committees, because our interfacing with standards committees is actually very important to us as a tool and our users as well. And so the C committee, they're really quite happy with the adoption of C23. C99 wasn't very well adopted, and C11 was a bit slow to be adopted, and C23 is going lightning fast in terms of Clang and GCCs picking up the new features. And so the committee is super appreciative of that. And the C++ committee is also really happy with Clang, but there is a little bit of concern about how the speed of us implementing some of the newer C++ features. And some of this is kind of an expectation setting thing, where in C++ 14 and 17, as features were being adopted into the standard at plenary, we were pressing the merge button. And so the committee got very used to us always being right on top of stuff. But C++ 20 was huge features, and they're not things that we could keep up with anywhere near that fast. So it's interesting to note that they've got little concerns there, but I think those concerns are kind of unwarranted in some cases. But one thing that I have seen that I think is important for us to keep in mind is both committees have members that are concerned about our extensions eating into the design space of the programming language. And it's not just us, it's all the implementations are kind of getting yelled at to some degree about having extensions that make it frustrating for the committees to add new features. So for example, a recent one in C++ was with reflection, they were using the caret symbol followed by an open curly brace to start a reflection expression. That's ambiguous for us because we have a blocks extension, and that's the start of a block literal. And so the C++ committee had to go back and figure out, okay, what's a different syntax to use? They said, we'll use double carets instead. Well, you could have immediately invoked blocks as well, and so that could be an XOR operator on an immediately invoked block. And so it's frustrating when we have these sort of extensions because they have to constantly work around them. But it's a double-edged sword because they also love having all of the extensions because that's how they get their newest features, and they get a lot of experience with features that are in progress. One thing that would be nice for us to work on is having a good mechanism for community collaboration on working on new features. Because the standards committee often wants to put out new features, but they want to make sure they're right. So they like an implementation to go implement them and give them feedback. The downside to that is we don't want to experiment on our users, and we also are penalized for being an early adopter because we implement it, and then we get users using it, and then the standards committee changes it, and we're left holding the bag trying to figure out how to support the existing users as well as the standards conforming thing. So overall, the external perception that I'm seeing is that users are excited by our extensions. Things like F-bound safety is just, there is a wild amount of excitement around that. Users definitely appreciate having a full suite of offerings. They like the fact that there's one place they can go for a compiler and a static analyzer and tooling and all of that sort of stuff. They appreciate how competitive we are in terms of the features and performance we have. And we still have very good diagnostic messages and standards conformance, and that is very important to our users, very important to our users. And then also, they really appreciate having the compatibility with GCC and the compatibility with MSVC because it allows them to try out Clang. So they'll get some sort of behavior from their existing compiler, and then they can go run it in Clang and see what happens. And that's a really important feature for our users. So the compatibility work we do is quite noticed by our users. Some of the less good stuff that I was noticing is that there are still people noticing that we're not fully conforming to the latest standards. That's a reasonable expectation for users. They want the newest, shiniest thing as fast as possible. There is definitely some frustration about compile time overheads getting slower. Our documentation is almost non-existent, and that is something we desperately need to have a lot of love on. And this last one was really kind of weird to me. I was not expecting it. But there's a perception out there that corporate interests dictate our project direction and that we're not a real open source project. This is weird to me because we have a lot of corporate contributors, but we have a lot of students, we have a lot of volunteers. We are an open source community that takes all comers. So I don't know necessarily how to combat this sort of perception on things. But it's interesting to note that there are users out there who think Clang was an Apple project, and then it became a Google project, and now it's an unowned project. And it's like, that's not how any of this works. So just to give you some of my thoughts on how I think things have been going, these are just my personal thoughts on stuff. I just think we're doing actually a really good job. And I'd like to give kudos to the entire community for this stuff because we've made some serious impactful changes with how we communicate with users. So for example, in Clang 13 and 14, our release notes were almost empty. And I found a comment on Hacker News from people saying they thought Clang was a dead project because we would put out releases and they would have 1 or 2 items in the release notes and that's it. And they're like, this project's going nowhere. They're not doing anything. And so we noticed this and we reacted to it. We changed some of our practices to really encourage people to write release notes. And now with 17, 18, and 19, we actually have a lot of release notes for our users. And they're like, oh, wow, this is actually a really active project. And there's a lot of things going on. We're also improving on how we interact with our users on issues. So it used to be users would file an issue and then it would just stagnate and nothing would happen, no one would look at it, and it would just be forgotten about for a long time. And now we have people who are actively triaging the issues and doing things like adding labels to them and trying to figure out if they can confirm the issue or not. And these sort of things really do impact our users in big ways because they don't feel like they're being ignored. And another big thing that I think we should be really proud of is we've grown. There are more people now helping out with code reviews, issue triage, answering questions on Discord or Discourse, anything like that, than I've ever seen before. And so that helps to grow. Like, as the community continues to grow and we get more people working on these things, it helps to snowball to continue that growth. So good work on all of this stuff. In terms of things that I would love to see us improve, documentation, especially around implementation-defined behaviors and extensions. It's really frustrating for users to have no idea how things work. And our source code is open to them and they can read it, but no one is going to actually sit down and read their compiler's source code to figure out how anything actually works. Testing is another big one. You saw that I was talking about conformance testing and how we have a whole lot of unknowns. There are commercial conformance testing suites out there. We just can't use any of them. They don't have a model that supports open source. And so we just have to figure out, what do we do? Like, if we can't go buy something off the shelf, how can we improve our conformance testing beyond just write a few tests and see what works? In terms of issues, I think we should be more reactive to issues than we have been. A lot of times people will write code, they'll add their features, everything seems to be working fine, and then they forget to go look at the issue tracker after they've landed it to see what was the fallout from that, what crashes have started happening, what kind of things are people running into. And so we do end up with a fair amount of regressions, which makes our release process harder because we have to fix a whole lot of stuff and then cherry pick them over into the release branch, and we could do better with our issue management. And then finally, growth. Even though we have been a growing community, my perception is we're growing mostly in areas of writing code, which is obviously really important, and it's the thing that a lot of people love doing. But that's not how we have a successful product in the marketplace that's really compelling to users, because users want things like documentation and a good issues list and that sort of stuff. How do we grow our community in these non-coding areas? How do we get people that are excited to work on QA processes or the website, that sort of stuff? But seriously, kudos, because we wouldn't have anything to offer anyone if it wasn't for the efforts of people in this room and people within our community. We all should give ourselves a big pat on the back because we are the ones who make Clang successful. And it is a very successful project. It is a very critical project in the marketplace, and we should be proud of that. So congratulations to all of you for everything that you do in the community. So now I'll open it up for questions.
Hey, I wanted to ask, apart from compilation time slowdowns, are there any other risks like security issues or runtime issues if we move to C++20 as the default language standard in Clang?
So part of the problem with us removing to C++20 as the required language standard is the support in all of the other compilers hasn't really been there. And so we run into a problem where we require last year's compiler for everybody, and then people who are on long-term support distributions have troubles contributing. You have to buy a new compiler if you're on Windows, those sort of things. So we will get there eventually, and I think we will see a lot of benefits when we're able to use the newer language standards and the features they have. But it's just kind of too early to make that move right now. But we will do it. We've been consistently doing that.
See, thank you.
You're welcome.
So you talked about a bunch of C++26 features that would be really good for improving quality of life for developers. What's the process for getting that stuff backported so that way the standard library can start using that stuff and delete with a reason, for example?
So if it's something that we can use as a conforming extension, we've traditionally tried backporting that stuff as much as we can. And that's been a double-edged sword for our users, because some users are like, this is great. I love it and it's conforming and I'm using just extensions, whatever. I don't compile in pedantic mode. Other users are like, I was using C++17, where are these other features coming from? Because my other compilers that I'm compiling with don't support that, or my previous version of Clang doesn't support that. And so I think we'll continue to do it where we can on backporting stuff, but we have to keep in mind the cost for it and the difficulties. So in terms of process for it though, write an RFC, propose a patch, that sort of thing. And so it's a good place to at least start the discussion on everything.
Thank you.
You're welcome.
Aaron, your talk was amazing, by the way. Thank you for that. I think you left out one small thing.
Okay.
So it's more of a comment than a question. One of the most impressive things that to me has happened recently with Clang is when you took the entire set of code owners and rebooted the entire thing and made it so that Clang was actually properly structured. And I think that was a huge lift for the community. I think it was a very thankless thing and very complicated, I'm sure, but I thought it was a great standard and a great idea and a great thing that other projects and sub-projects could learn from. So thank you for doing that.
Oh, thank you. Thank you.
The graph about the defect reports was super interesting, and I'm sure folks want to chip in and help out. Is there anything like a monthly meeting or bi-weekly meeting that folks should stop by and attend if they're interested in helping?
Yes, as a matter of fact, there is. Every 2 weeks, there's a language working group meeting that happens. It's on the community calendar. It's every other Wednesday. I think it's first and third Wednesday of the month, sort of thing. And it's basically a chance for anybody who's working on any sort of standards conformance type stuff to come, A, talk about what it is you're working on to make sure that we're not duplicating effort across people's work, and B, to ask for help. So it's a very good resource for kind of getting into doing standards conformance work. And there are folks in the community, Vlad Sobrenikov, for example, has been working on standards conformance DR testing specifically for C++. And so we have people who are doing this work that I'm certain would be willing to step up and help integrate if you want to do more help on writing those kinds of tests. The most difficult thing with doing that is it oftentimes requires you to read the standard. And it's not an easy document to read. But the nice thing is there are a group of people who will help you with that standard. So you can come to the language working group meeting and go, how do I write a test for this sort of thing? Is it even possible to test? So thank you, Nick.
Great. Well, let's thank Aaron again.